Okay, so we're back for part 2 of the derivatives of logarithmic functions, and we're going to be talking about using different types of bases. So this is the general exponential form is f of x is equal to a to the x power, and the general logarithmic form is log with the base of a of x is equal to b, if and only if a to the b power is equal to x. So this is what we're going to be really focusing on right now. So we're given it in this form, and we're going to write it in this form and solve for x, okay, without a calculator. Evaluating without a calculator. So in a's place, I have 2, and in x's place, I have 16. So now I'm going to plug this into this form and solve for what I'm missing. I'm solving for b. Okay, so I have 2 to the b power is equal to 16. So then I have to think, 2 to what power is going to give me 16? Well, I know 2 to the second power is 4, 2 to the third power is 8. So if I try 2 to the fourth power, that should give me 16, so b is 4. 2 to the fourth power, if I want to check, is equal to 16. Okay, next one, a is 10, x is 1 and over 100. Okay, so I plug that in, so I have 10 b is equal to 1 over 100. Okay, so we know when it's 1 over something, we're going to be dealing with a negative exponent. And so I know that b is going to be a negative exponent. So now 10 to what power would give us 100? Well, 10 times 10 is 100, and that would be to the second power, so it's b to the negative second power. Okay, so these are our answers right here. This is what we're solving for. Okay. So the next thing we need to do is move on to the next one, which a in this case is 2, b is 1 over 32. So just like the last one. So we have, oh, that's x. So we have 2 to the b power is equal to 1 over 32. Okay, so we know that b is going to be negative again, and we have to figure out what power, when we put it near 2, is going to give us 32. Okay, so if I do 2 to the 5th power, that should give us 32, so it would be to the 5th. And you can double check on the calculator. So you go 2 to the negative 5th, and that should give you 1 over 32. Okay? Log with the base 5 of 125. So we have a is 5, x is 125. So 5 to b equals to 125. What power would give us 5? 5 would give us 125. 5 times 5 is 25. 25 times 5 is 125, so it's 3 times. Third power. Okay? The next thing we're getting into is using the change of base formula. Okay, so we're going to be given it in this form, and we're going to have to change the base. So we're going to write the natural log of x over the natural log of a. So whatever's in x's place goes up top with the natural log, and then a on the bottom. Okay, so let's do the first one so you can see what I'm talking about. So we're using the formula and a calculator to evaluate each logarithm. So 2 is in a's power and 5 is in x power. So I write natural log of 5 over the natural log of 2. And then you grab your calculator. I do, let's see if I can, natural log of 5 divided by natural log of 2. Yep, so you just type it right in. So you hit ln, natural log of 5, close the parenthesis, divided by the natural log of 2, close the parenthesis, so I get 2.32. And that's all they want. This is an approximation. Okay, so log 3 of 18. So we have the natural log of 18 over the natural log of 3, and we're solving. Natural log of 18, close parenthesis, natural log of 3. We're dividing 2.63. Next one, log 4 of 80. So we have the natural log of 80 divided by the natural log of 4. Natural log of 80 divided by the natural log of 4, 3.16. Last but not least, we have natural log. We have natural log of 0.25 over natural log of 16. Natural log 0.25 25 divided by natural log of 16. Negative 0.5. Just like that. So use the change of base formula to set it up. Make sure you set it up accordingly, okay? And then just plug it into the calculator.